Okay, students, today we're on lesson 7-6, which is pages 437 to 441. Get those tore out and ready to go. And if you remember, just yesterday we were talking about nets. And a net is what a three-dimensional object looks like when you cut it and lay it out flat. Okay, so there was a reason why we were learning how to do that. Because if I ask you to find me the surface area, face, remember we learned what a face was? This box has got 6 faces. So the surface area, I want to know the area of each one of these sides of this box. That's surface area. Okay, so if we have it laid out flat, it makes it a little bit easier. So Marianne orders boxes to pack gifts. When they arrive, she finds flat pieces of cardboard as shown below. Marianne needs to cover each face of the box with green paper. So what's the least amount of paper needed to cover each box? That means if we didn't overlap it anywhere, if it just came to the edge and met, and you know we don't wrap boxes like that. We always wrap over. So it said the least amount of paper, so we're gonna pretend like we're not overlapping any side anywhere. Okay, so instead of redrawing all this, since they already have it drawn once right here, instead of redrawing that down here on the dot paper, I'm going to just go ahead and go up here to each one of these squares. You see that it's a cube. Okay, because it's a 9, a 9, a 9, it's 9 every direction. So each one of these links is a 9, which makes this be a cube. And you understand a cube means that the length, the width, and the height are all the same number. So this is a 9, this is a 9, and this is a 9. It's 9 in every direction. So we have 6 sides, 1, 2, 3, 4, 5, 6 sides, 6 faces, okay? 6 faces, and each one of those faces, if I want to find the area of it, it's going to be a length times width or a base times height. So that's going to be a 9 times a 9, which is going to be 81 square inches. And I have how many of them? 1, 2, 3, 4, 5, 6. There's 6 faces on every rectangular prism. And so, if I want to know the total area, move this up a little bit. The area total, surface area, and I'm going to call it SA for surface area, is going to be 81 times 6. So you go to your calculator and tell me what 81 times 6 is. 486, and that would be inches squared. I'm finding area. Now that's the least amount of cardboard to make that box that size. That would be the least amount. If I wanted to cover that and overlap it, I'd need more than that. Okay, let's look down here at Focus on Math Practices. Suppose Marianne has only one large sheet of green paper that is 15 by 30 inches. Is the area of this sheet of paper great enough to cover all the faces of the box? Well, we know that we need 486 inches squared because we just calculated that. Okay? So we want to see how much she's got. She's got 15 by 30. Well, 3 times 15 is 45, and if I put a 0 on that, she's got 450 inches squared. If you don't believe that, then you go punch in your calculator 15 times 30. Okay? So it says, this is what she has. She has this much. This is what we need. So, what was the question? Is the area of this sheet of paper great enough? Is it big enough to cover this? And the answer is no. She needs 486 inches squared, and she only has 450 square inches. Okay, turn your paper over. Let's look at example 1. I believe this example is done for us. The question is, how can you find the surface area of a prism? Remember, on a prism, we have a top and a bottom with the same dimensions. We have a front and a back with the same dimensions, and we have a left and a right with the same dimensions. Okay? So here's a 10 by 6, and here's a 10 by 6. 10 by 6 is the left and the right. This is a left. This is a right. We have a 6 by 8. 6 by 8. So this is this front piece. This is a front. And this one here is the back. And we have a 6 by 10. Let's see, I did that incorrectly a while ago. The 8 by 10 is the front and the back. I'm sorry, let me get my picture here. Okay, so this piece is an 8 by 6. That's the front and the back. So we named it correctly. This side is a 6 by 10. The 6 by 10 is the left and the right. So now we have an 8 by 10. I'm sorry, I got lost there in what I had. And this is a top and a bottom. So every time we have a prism, we're going to have a top and a bottom, a left and a right, and a front and a back. So there's going to be 3 pairs of numbers that are the same. Notice they did this over here. They drew their net. They calculated, here's 2 that's alike, 2 that's alike, 2 that's alike. Put it all together. She needs 376 square inches of paper. Okay, so let's go down here and do the try it. Y'all should be good at finding the area of rectangles and squares by now, because we do it a lot. Length times width or base times height. Okay, so here's how we're going to do this. I don't like it when they use different variables all the time. They're using a length and a width and a height and a length and a height. I want it to make sense to you. So we're going to point to this one right here. And this is a length and a width. A length would be this. We're going to call that the L, this the W, and this the H. Okay? So, to make it match theirs, so we want 2 lengths times width. So that would be the top and the bottom. So this is the top and the bottom, which is a 4, because that's a 4, so it's a 4 by 2. So this is a 4 times 2 of them. There's top and a bottom. Then we want the width, the 2, and the height. So that's the left and the right. So this is the left and right sides, right there. So I've got 2 times 2 times 3. And then we need a front and a back. We have a front and a back. So we're going to add that on. I have 2, because it's a front and a back. And then I have, this is a 4, and this is a 3. Times 4 times 3. Then we do each one of those. Of course, we multiply before we add. So 2 times 4 is 8, times 2 is 16. 2 times 2 is 4, times 3 is 12. 2 times 4 is 8, times 3 is 24. And I want to add them all up to get surface area. Add all those numbers up. 16 plus 12 plus 24. And you get a total of 52. So the surface area is 52 centimeters squared. Okay. Just like we did the one on the previous page. Okay, now, convince me. Why are LW, WH, and LH each multiplied by 2? What would you say there? Okay. I would like for you to put that in your own words. And you can use what we've been saying, because the top and bottom are the same dimensions. That's a word you need to learn. The left and right are the same dimensions. And the front and back are the same dimensions. You have to know that when you're drawing the net. You have to know it when you're finding the surface area. Notice, once again, no new formulas are being introduced here. We're using some of the same information we learned long ago. All right, let's go to example 2. Example 2 is worked out for you. Find the surface area of a cube. What did I tell you a cube meant? It meant it was the same length in every direction. Its length, width, height, its base, width, and height are all the same number. Okay, so if we have 6 of them, if it's a cube, we can find the area of one and multiply it by 6. We can find the area of one. Well, they didn't do. What's that little squared right there? What does that mean? Because I'm telling you that surface area is 6 times 0.5 times 0.5. Length times width to get one of them, and then multiply by 6. Oh, but what if the number is the same number multiplied together? Could it be written as that number squared? And the answer is yes. Okay? So if it's a cube, you're going to find the area of just one of them and then multiply it by 6. Okay, keep that in mind. It's a shortcut. We like shortcuts. All right, look at example 3. This is a triangular prism. The bases are the two triangles. Triangular area of the bases, 1/2 base times height. So we have 1/2 the base times the height. That gets me one of them, but there's 2 of them. So I need to multiply 2 times 54, and I get, where is it? I lost it. Oh, right here. Here's where they put it in there. Okay, and then they did the bottom. And these rectangles are not the same size. We have a 9 by 18. There's this one. We have a 15 by 18. There's this one. And we have a 12 by 18. There is that one. So we have 3 rectangles. And we have two triangular bases. So here's the area of the 2 bases plus all 3 of the rectangles added together for a total of 756 centimeters squared. Okay, here's the 3D version. Here's the 2D version. This is the net. Okay, this is the polyhedron. Polyhedron means 3D. Okay, all right. We're going to skip the try because we're going to do that on the homework here in just a little bit. Okay, here is your key concept. This is always a good thing to hang on to and keep. If you were taking notes, I'd be cutting these things out or something and putting them in my notes. You should know yourself. What do I need to do to remember this? And that's what you should do. And everybody's different. Okay. Let's go to the do you understand. How can you find the surface area of a prism? How can we find the surface area of that right there? we're going to find the area of the two bases, find the area of the sides, no matter how many of them there are, and add it all up. See, we're going to find these two bases. The bases are the two that are parallel sets, these two end pieces. Okay, we're going to find those. We're going to find all those rectangular sides around there, and we're going to add it all together. Now, could this be considered the base down here? Yes, it could. So I could say the top and the bottom is the base, and then I would have four sides. That side, that side, that side, and this front side. On a box, it doesn't matter which two sides you call the bases, because every pair is parallel. It doesn't have to be what it's sitting on. All right, could you use the formula for surface area of a rectangular prism to find the surface area of a cube? What do you think the answer to that is? Absolutely. Absolutely. Works the same way. There's a shortcut on a cube, but we don't have to use the shortcut. We can do it the same way as the shoebox. Okay, which faces of a rectangular prism always have to be the same area? Well, we've done this, and I've already told you the answer to this many times. The top and bottom have to be the same. The left and right have to be the same. And the front and back. Front and back. These have to be the same. These have to be the same. And these have to be the same. If they're not, it's not a prism. Okay, number 4. What does it mean to find surface area? It means to find the area of, and I'm going to put this in capital letters, all the faces as a total. Okay, let's look at number 5. Let's get started. 6 sides to every box. So there's 6 faces here, there's 6 faces here. So number 5 and number 6 are going to be done somewhat similar. Alright, this is like a shoebox. I've got a top and a bottom. Okay, at this point, I'm going to abbreviate T/B. And that means the area of T/ the top and the bottom. So the area is going to be 2 times 10 times 2. No, excuse me, 5. This is a 5. So 10 times 5. And I'm going to get an answer for that. Then I'm going to do the area of the left/right. Here, 5 by 2. I've got 2 of them. That's 5 by 2s. And then I need a front/back. So that's 2 of those. And this is a 2 by 10. 2 by 10. And I'm going to figure all of these up, and then I'm going to add them up. Well, 2 times 10 is 20. 20 times 5 is 100. 2 times 5 is 10. 10 times 2 is 20. And I'm going to line up my digits here. 2 times 2 is 4. 4 times 10 is 40. That's a 0, and that's a 6, and that's a 100, and this is feet squared. So your answer should be 160 feet squared. We're going to do a top and bottom, a left and right, and a front and a back. Now when we get to number 6, we're going to do it two ways. The first way is going to be just like this. Let's do the top and the bottom. Top slash bottom. And this is area. We're doing the area of the top slash bottom. So this is a 7 by 7. It's 7 every direction, isn't it? So I got 2 that's a 7 by 7. The area of the left slash right is a 7 by 7, and there's 2 of them. The area of the front slash back is 7 by 7. So this is 49 times 2, whatever that is 98, I believe. So there's 98, and this one's going to be 98, and this one's going to be 98, and I need the total, so I'm going to add that up, and I get 294, and that's centimeters squared. Surface area, all of it together. Now remember, we could have done that a little easier way, because it's cube. Cubes are the same in every direction. So my surface area for a cube could be 6 times 7 times 7. So that's 6 times 49. Well, 6 times 49, guess what that is? Again, it's 294. And that's centimeters squared. Same answer we got before. Or I could have even said it is 6 times 7 squared. And 7 squared is 49. So that's 6 times 49. So again, it's 294 centimeters squared. Surface area. Okay? So you could have done this one like this, or this, or this. Okay, let's look at number 7. And so far, all we've needed to know is how to find the area of a rectangle so far. Well, now we got to remember triangles also. And I'm going to do my, I'm going to do it the same way, kind of like this, but I'm going to do the surface area of the triangles. There's 2 of them. My formula is times 1/2 the base times the height. Well, the base of my triangular base is 2 and 2. Okay, why is this 2 here? Is because I have 2 bases, one on this end and one on this end. Then I have 3 rectangles, and I don't believe they're the same size. So I'm going to do the surface area of the back. The back is a 2 by 3. So it's just a 2 times 3. The top is this slanted piece right here. So the surface area of the top is a 2.8 times 3. And we'll figure that out in a minute when we pick up our calculators. And then we got the piece that it's sitting on, which is a 2 by 3. So there was 2 of them that was the same. There was 2 that was the same. 2 by 3. This is a 3. And this was a 2 by 3. So instead of doing another one, I'm just going to come up here and put a 2 beside that because there was 2 rectangles that were the same. Now let's work through these numbers. 2 times 1/2 is 1. 1 times 2 is 2, and 2 times 2 is 4. Or 2 times 2 is 4. Half of 4 is 2, and 2 times 2 is 4. Any order you want to multiply those 4 in, go for it, because you're going to get 4, either way you do it. And 2 times 2 is 4 times 3 is 12. And then I need a 2.8 times 3. Well, I'm going to get my calculator for that one. Make sure I don't make a mistake. And I get 8.4. Now, since this one got a decimal, we're going to put a decimal 0 on those and add them up. Plus 12 plus 4. And we should get 24.4, and that would be meters squared. And there you have it. And it's not hard. You have to do it in pieces and put the pieces together. And you're going to get some practice. Get page 441 out and let's look at it. Okay, on problem number 8, it's a cube. We've done one like that. On number 6, number 9 is a triangular prism. We've done one like that on number 7. 10, 11, was like number 5. Number 12 is like number 9. So we've done one like every one of these. So if you paid attention and you wrote the work down, then you will know how to do these. Plus you have a classroom teacher to help you all over the place. I seriously would do a top and a bottom, a front and a back, a left and a right, and then total it all up. Okay, teachers, you have a vocabulary page, a reteaching page. I highly encourage you to have those kids doing that vocabulary and discussing it in class, making sure they understand all the vocabulary. And I'm going to let you go get busy, and I'll see you next time.